liquids. All right. Now, let me tell you generally. Now, notice that this does not say always. Notice that this does not say 100% of the time or nothing. This says kind of some trend you can go about a drawing. The first thing is if something has a low molecular weight, it is likely, look at this word likely, not always. It is likely a gas. Likely. Now what is a low molecular weight? Well, who the hell knows what low means, right? Let's give some examples. Oxygen is a what? Liquid, gas? It's a gas. Fluorine is a gas. Helium is a gas. Nitrogen is a gas. Hydrogen is a gas. There are other gases. I'm just stopping for a pattern. Okay? Now what is the molecular weight here? 32 grams per mole. What is it here? 19. Is it 19 for fluorine? I think it's 19 for fluorine. Somebody help me out. All right, so 19 plus 19 is going to be 38. This is 4. This is 28. This is 2. You get the idea. These are low, like under 50. Now, you know, we're taping this, so I know what I said. I didn't say that all gases are under 50. I said, no, it's just a common theme. Okay? Now, as the molecular weight goes up, you have what are called moderate molecular weight things. And those are liquids. Okay? Something like octane, C8H18. Something like decane, C10H22. Now let's examine those molecular weights. Well, 8 times 12 plus 18 is 114. Well, that's a liquid. 10 times 12 is 120 plus 22 is 142. That's a liquid. And then as you get up into something that's a high molecular weight, something like a fat, all right, something like a candle wax, a paraffin, this huge elaborate structure, cellulose, like a tree bark, okay, skin cells. Those are huge molecular weights, and they tend to be solids, okay? But molecular weights are not the only governing pattern. Here's why. Under this prediction, what would you predict H2O to be? Water. Well, no, wait a minute. How much does H2O weigh? 18. All right. So where does it roughly fall in the category here? It kind of falls in a gas, right? So would you not predict that you would not have a bottle of water? It would be impossible. You would just have a gas of water. All right. Well, that's what you would predict, but naturally that's not what happens. Okay? What happens in water's specific scenario is for something to turn into a gas. Okay? If this is a liquid down here, okay, so a wavy liquid, for it to turn into a gas, gas particles have to leave the liquid, molecules have to leave the liquid and turn into gases. Are you with me? All right. Now, here's what happens with water. Water's little stuff structure looks like this. Okay? And each water is connected between an oxygen and a hydrogen, and this goes on for infinity. A lot of times they call this the polymer of water. Now what are these little dots right here called? These little dots are what are called the hydrogen bond. Okay. Now this is the third type of bond we've got here, and the only type that we're going to have this semester, right? There are other types of attractions, but the first type was ionic. Now you know that that right there was VVS, very, very strong. The strongest. Then the second type was covalent, and that's just VS, very strong. And the third type is hydrogen, and that's just strong. And they go in that order. Okay. Now a hydrogen bond is strong enough to be measured. It is an honest-to-God force. All right. So for this liquid to turn into the gas, what has to happen is that dotted line has to break and be severed, and that then will pull up here in the gas phase. Are you with me? All right, so that is a hydrogen bond. So what type of things undergo hydrogen bonding? Well, you have to have a hydrogen that is directly bound to an oxygen, or the hydrogen must be directly bound to a nitrogen, or a hydrogen must be directly bound to a fluorine. One of those three things will create a hydrogen bonded network. Now, why does this have a relative high boiling point? It does, right? It's 100 degrees centigrade. You have to cook on the bottom of this quite some time. And when you start cooking, these molecules start vibrating, and then every now and then that bond will crack and it'll release up. All right? So, why do you have to cook on this so hard for it to go up into the room? The reason is you've got this hydrogen bond. You've got an attraction that goes between an oxygen and a hydrogen of another molecule. Okay? Now, let me ask you this. There's something out there called dimethyl ether. All right? And I'm going to show you what dimethyl ether looks like. This is a methyl group here. All right. Here's another methyl group. That's what's called dimethyl ether. Now, how much does that joker weigh? Well, it's going to be 15 and 15 is 30 plus another 16. So it's going to be 46. This thing weighs 46. Okay. And it's a gas. This comes in a stainless steel cylinder, a gas cylinder. But look at this. This weighs 18 and this don't. Now what is the difference between this and this? Do you have a hydrogen that is directly bound to an oxygen here? So is there any hydrogen bonding? No, there's not. Now let's take a look at this one. This is diethyl ether. This is the ethyl they used to use to put people to sleep. It had some real nasty side effects. All right, how much does this guy weigh? Well, it would be 29 and 29 plus 16. It weighs 74. And it turns out this is a liquid, but it's very volatile. Now, what does your textbook say about volatile? Volatile compounds are things that evaporate easily. Now, there is no line about what is easily, okay? Let me give you some examples of something that's volatile. This would be volatile. You open up ether, and you can smell it right away. What does that mean? That means it's evaporating and going up into the room with you. Matter of fact, you have to be careful, like if you're working in an ether lab, not to be using a Bunsen burner right next door, because that gas will travel over there and then you got a fire going. Gasoline is relatively volatile, right? What happens if you take gasoline and spill it on the concrete ground? Will it evaporate shortly or not evaporate at all? What's that now? It evaporates shortly. Water's kind of a cutoff, right? I mean, you spill water out, it'll evaporate. It's somewhat volatile. But what about motor oil? That's not volatile. You spill that joker on the concrete, it's going to stay there a while. Okay? So those are what they call volatile and not volatile.